NEC Article 280 provides guidance on installing surge arresters but does not mandate their installation on service entrances. However, NEC Article 230.90 mandates surge protection for services in specific locations, detailed in 230.91 through 230.98. 230.90a states that surge protection shall be provided for each service and feeder where conductors enter a building from overhead lines outside the building. 230.90 says surge protection shall be provided for each service in other buildings where there is a voltage of 300 volts or higher phase to phase, or 175 volts or higher phase to ground. Furthermore, NEC Article 285.24 will require surge arresters on substations with specific characteristics. 285.24 states that surge arresters shall be applied to each overhead incoming line at all substations and installed per the manufacturer's instructions. Remember that the NEC represents the minimum safety standards. Local jurisdictions might impose extra requirements for surge arresters. Always consult your local building inspector to identify supplementary regulations applicable in your vicinity. An inspector might interpret the NEC as not requiring surge arresters on services outside the specified areas in NEC Articles 230.90 and 285.24. However, installing surge arresters on all services is a good practice. They protect equipment from power surge damage and are relatively inexpensive to install. Consider these factors when deciding whether to implement surge protection beyond the minimum code requirements. Firstly, understand your local jurisdiction's interpretation and enforcement of the NEC. What might have been accepted or rejected in the past could vary based on changes in code interpretations, inspector discretion, or specific project details. Secondly, consider the potential cost savings from preventing damage due to surges. Surge arresters can help protect sensitive electronic equipment from being damaged by spikes in voltage, which can save money in the long run. Thirdly, evaluate the specific risk factors associated with your location. For instance, areas prone to lightning strikes or grid instability may benefit more from comprehensive surge protection. Fourthly, choose the appropriate type and rating of surge arrestor for your specific application. Different arresters are designed to handle different voltage levels and surge currents. Consulting with an electrical engineer can help you determine the best option for your needs. Fifthly, ensure the surge arrestor is properly installed according to the manufacturer's instructions and relevant electrical codes. Improper installation can render the arrestor ineffective or even create a safety hazard. Sixthly, regularly inspect and maintain surge arresters to ensure they are functioning correctly. Over time, surge arresters can degrade or fail due to repeated exposure to surges. Replacing them as needed can help maintain continuous protection. Let's delve deeper into the technical aspects of surge arresters to understand their function and selection criteria better. Surge arresters, also known as surge protective devices or SPD, are designed to limit transient voltages by diverting surge current. They achieve this by providing a low impedance path to ground for the surge current, effectively clamping the voltage to a safe level. There are different types of surge arresters, each with its own characteristics and applications. The most common types include metal oxide varistors MOV, silicon avalanche diodes SAD, and gas discharge tubes GDT. Metal oxide varistors are the most widely used type of surge arrestor due to their relatively low cost, high surge current capacity, and fast response time. They consist of a ceramic material with a nonlinear voltage current characteristic. When the voltage across the MOV exceeds its clamping voltage, the resistance of the MOV decreases dramatically, allowing the surge current to flow through it into ground. Silicon avalanche diodes are another type of surge arrestor that offers very fast response times and low clamping voltages. They are often used to protect sensitive electronic circuits from electrostatic discharge (ESD) and other fast transient events. However, SAD typically have lower surge current capacity compared to MOV. Gas discharge tubes are surge arresters that consist of a sealed glass or ceramic tube filled with an inert gas. When the voltage across the GDT exceeds its breakdown voltage, the gas ionizes, creating a low impedance path to ground for the surge current. GDT offer very high surge current capacity and are often used in high-energy surge protection applications. The selection of a surge arrestor depends on several factors, including the voltage level of the protected circuit, the expected surge current, the desired clamping voltage, and the application environment. It is important to choose a surge arrestor that is properly rated for the intended application to ensure effective surge protection. Surge arrestors are typically rated by their maximum continuous operating voltage Markov, surge current capacity, and clamping voltage. The Markov is the maximum voltage that the surge arrestor can withstand continuously without degrading or failing. The surge current capacity is the maximum surge current that the arrestor can safely divert to ground. The clamping voltage is the maximum voltage that the arrestor will allow to pass through to the protected circuit during a surge event. In addition to these basic ratings, surge arrestors may also be characterized by their response time, energy absorption capability, and other performance parameters. It is important to consider all of these factors when selecting a surge arrestor to ensure that it will provide adequate protection for the intended application. The installation of surge arrestors is also critical to their effectiveness. Surge arrestors should be installed as close as possible to the equipment being protected to minimize the length of the wiring between the arrestor and the equipment. This helps to reduce the inductance of the wiring, which can impede the flow of surge current and increase the clamping voltage. Surge arrestors should also be properly grounded to provide a low impedance path to ground for the surge current. The grounding conductor should be as short and direct as possible to minimize inductance. In some cases, it may be necessary to use multiple surge arrestors in a coordinated protection scheme to provide comprehensive surge protection. A coordinated protection scheme typically involves installing surge arrestors at multiple levels of the electrical system, such as at the service entrance, at distribution panels, and at individual equipment. This helps to ensure that surge current is diverted to ground as quickly and effectively as possible, minimizing the risk of damage to sensitive electronic equipment. Another important consideration is the type of surge protection required for different types of equipment. Some equipment, such as computers and other electronic devices, are more susceptible to damage from voltage surges than others. It may be necessary to use specialized surge protectors with enhanced filtering and clamping capabilities to protect these devices. In addition to surge arrestors, other surge protection devices, such as surge suppressors and line conditioners, can also be used to protect equipment from voltage surges. Surge suppressors are devices that are designed to block or reduce the amplitude of voltage surges. They typically use components such as MOV, SADs, and GDT to clamp the voltage to a safe level. Line conditioners are devices that are designed to regulate the voltage and filter out noise and interference on the power line. They can help to protect equipment from voltage sags, voltage swells, and other power quality problems. To summarize, understanding NEC requirements for surge arrestors is vital for electrical installations. While NEC Article 280 provides installation guidelines, Articles 230.90 and 285.24 AT will mandate surge protection in specific scenarios such as overhead lines and substations. Always verify local codes for any additional requirements beyond the NEC minimums. Choosing to install surge arrestors even when not strictly mandated can be a beneficial decision to safeguard equipment. Consider local interpretations, cost savings, risk factors, proper surge arrestor types and ratings, installation methods, and regular maintenance. Surge arrestors, or SPDs, limit transient voltages by diverting surge current. Common types include MOV, SADs, and GDT, each with varying characteristics and applications. Selection depends on voltage level, surge current, clamping voltage, and environment. Proper installation and grounding are essential. Coordinated protection schemes involving multiple arrestors can offer comprehensive defense. Specialized surge protectors may be needed for sensitive electronics. Other devices like surge suppressors and line conditioners can also be used. By thoroughly understanding these factors, you can ensure that your electrical systems are adequately protected from voltage surges.